Alright, welcome back everybody. As I told Michael, I was going to do a series on this little RCA Victor. Let's see, it's 40X-54. It's called the treasure chest, made about 1939. You saw in the first video. This got broke in transit, which I hate, and Michael did too. But I've ordered a new one. So as far as the cabinet, I think the cabinet is going to be just fine, just like it is, except need to put the ropes in, and that's I'm going to pick some good cotton ropes for that, and then replace this, and that's already on order. So let's take this thing apart. The knobs, they're just got the little plastic clip, or the metal clip in there, and they just pull off. Of course, the tuner worked also, see, so it everything looks like it's working pretty good. So we'll put these in a safe place, and now let's turn this thing around. The Colorama's still sitting over there. I'm still waiting on parts for it, but hopefully we'll get that off the bench. This has screws it pulled out through here. I think that was part of the damage. There's a loop antenna, which has got some wing nuts that hold it on. There's two of those. Now they're wired to a terminal block on the back. Okay, well, guess what? It's not. So, I don't know if I can get good light here or not, but these two wires go to those terminal blocks. And I'm just looking at it. There's another piece here, and I'm not sure. We'll have to investigate this a little bit later on. There may be some more to this, but we'll put the screws and this antenna off to the side for right now. Alright, in theory this should pull out. Let's see if it will. I said it would. No. Still one more thing. Maybe, sorry about that. This is held in with a screw here and a screw here, and this is the only screw. Now I found one in the box, so it looks like this, so I've saved that. So I will put that to the side. Now this should come right out. It should. Ouch. And as you can see, there's the rest of our dial. Two more pieces. But inside here looks pretty good. It'll need a little cleaning, but other than that, it's fine. And I believe that dial face is glued in, so we'll have to try to remove that when the new one comes. So let's set this to the side for now. Alright, there's no lamp, and it's loose there. Let's look at the speaker and see what it looks like. One hole punched in it, and looks like one in the very center. I don't know where that would have come from. The dial cord, that's what turns that. It looks in pretty decent shape. A little corrosion on the RF. Let me throw this glass away. Okay. Whoops. getting back here. Now let's look. Let's take a look here. All in all, it's not too bad. The tubes, two metal tubes. And let's look at our tubes here. That is a 50L6. Now these came with either a 35L6 or a 50L6. So that's what that is. There's a 12SQ7, the 12SK7, and let's see, what would this be? Oh, hang on. There's another piece of my hate that. There's the 12SA7 and the 12SQ7. Where's the key? All right, so this must be the 35. Must be the rectifier tube, and I do not like getting that by the glass. Always pull these by the base if you can. There's the 35Z5. So that is the tube complement, which is the All-American 5. So let's see if we can look at this. Well, maybe I can get some light here. This is basically the power supply for it. You see the plug comes into the switch, and then it goes through all the filaments. SQ7, SK7, SA7, there's the 50L6, goes through a resistor, which if it has the this is used, this 86 ohm is used if it's the 50L6 is used, according to the notes here. And then this is the 35Z5. Notice I've written some of the pin numbers in on this. This is the rectifier tube. And also your dial lamp goes across one of the heaters. Let's see, that's pin 2 and 2 and 3 is what the dial light should be going across. So let's do some testing here. This is the filaments of all the tubes that goes across there, and the All-American 5, and they should total close to 120 volts, 117 volts, or very close to anyway. This has got an additional resistor, so it's going to be a little bit less. The one thing that they have in common, and there's questions, is how does the tubes know to drop 12 volts, and how did the tube know to drop 50 volt, and how does the tube know to drop 35 volts? Well, it all deals with the resistance and the current they draw. And in these particular tubes, they all draw 150 milliamps. Okay? And by doing that, you can determine the resistance of them. And let's see, the 50 volt one, you take 50 volt on the 50L6 and divide it by 150 milliamps, 0.15 amps, and that's 333 ohms. Then across the 12 volt ones, all three of them, you divide the 12 volt divided by the 0.15, and that gives you 80 volts a piece, or 80 ohms a piece. 1, 2, 3. There's 3 80s together. And then the 35 ohm, or 35 volt, you divide that by 0.15 amps, and that's 233. So if you add all those together, it's approximately 807 ohms. You add the 86 across that, and you get roughly 893 or something like that. So if this switch is closed and you read across there, you should be able to read the filaments, and it should read 900 ohms or so. Well, let's just check it out. Let's take the old ohm meter. Let's see if I can get all this in one frame without glare. There we go. We can just do it across the cord. Let's make sure the Let's see if we can make sure that switch is on. All right, that's on. So if the cord is good, which we're questioning that already, but in theory, we should have roughly 900 ohms across the cord. Okay, what do we got? We got, and it's running around 20, 23, 24 meg. That doesn't sound like there's any continuity going there at all. I would expect it to be a lot lower than that. So what does that tell us? It tells us that the cord could be bad. It tells us that the tube filaments, one of those may be opened up. So let's pull these tubes and check them. That's low hanging fruit, guys. If you've got a tube tester, just check them right off the bat. But you can test them individually across the filaments and see if you've got an opening. Okay, let's just do a quick and dirty check with our ohm meter on the filaments. This is the 12 SK7 and the heaters. And guys, when I download my schematics for my radios, I go ahead and go to Frank's or some other place and download the tube data as a PDF file and put it in my files with the same schematic, so that I have the tubes data in one spot. So and we already talked a little bit. I didn't mention it in the initial video, but then I think I mentioned it again, that those resistances in theory is when they're warmed up. So they're going to be a lot lower. So here's our key. So pin 1, 2, 2 and 7. And let's see what kind of continuity we have here. That's about 12.87, a little over 12 ohms. So I feel pretty good that that one's okay. Let's pull the SQ7 out, and I believe it has a different animal. I think it's a different animal. I believe it's pins 7 and 8 are the heaters. So I believe, let's double check that here, make sure. Now we're looking at a little over 12 ohms on that one also, and that makes sense. Let's go to I'm going to mess around and push a finger through that speaker. Yeah, but 12 SA7. I don't know if you can read that or not, but it's scratched on it bad. That may be an indication that it's bad. We don't know. But anyway, okay, we just tested that, so we'll go back to pin 2 and 7. That's the configuration for it. And let's see what that says. That's around 12. It's fitting. It's fitting in there what it's supposed to. Okay, let's pull the rectifier. Right, let's check the rectifier tube. Wow, that's nice. Okay, this is the 35Z5. The filaments, pin 2 and 7. Now there is a tap between 2 and 3 where the dial lamp goes. So let's check our 2 and 7 right off the bat and see what we got. Do this. There's pin 1, 2, and 7. And we're looking at about 36 ohms or so, 35. Now let's go to 7 and 3. There's 27. So let's go between 2 and 3. It's a little over 8 ohms there. So as far as a filament, now something to keep in mind, just because you're checking the filaments doesn't mean the tube's good. But the guys that don't have a tube checker, is a good way to check in the power supply to make sure that the filaments are will conduct. And as you saw in the beginning, we checked and we had an infinity per se. It was in the megs. So let's check the 50L6, and there's pin 2 and there's pin 7. Okay, I'm not getting anything. So I believe that the filament of this 50L6 is bad. I'm going to pull these tubes and I'm going to take them upstairs and I'm going to put them on the tube checker and check them. And I'll show you what I come up with. Okay, I pulled all the tubes, took them to my Hickok and checked them. The one that was marked bad was good. Now the 12SQ7, one part of it was a little weak. The others tested good. Now this was the bad 50L6. Now this is one that I've pulled out of another radio off my shelf. And let's check pins 2 to 7 and see what we get there. Let's see if we can get the glare off. Okay, we've got about 50 ohms, 48 ohms or so. So let's stick this in the socket. Now I'm showing you this technique for the guys that don't have a tube checker, and especially with an AA5 you can check that. So I still don't have a bulb in there, but let's check across here. Now with it warm, in theory it should have been what, 893 ohms if it was warmed up, but we're testing this cold, so the resistance is going to be a little bit lower. So let's check and see what we've got here. So we're doing 0.7, 692 ohms. That's pretty close. I think that we've got continuity in here, and I think it'll fire up now. So I'm gonna admit something to you now. Before I started taking this apart, I did put it on the Variac and try to bring it up, and I had zero current whatsoever. So I kind of suspected that we didn't have any continuity in the tubes, and that's the reason I went this route, to show you how to check it if you don't have a tube checker. Now, like I say, it doesn't say the tubes are good or bad. It just says the filaments, or one of those were open, so we found out which one it was. Now that could have been the bad cord, could have been an open switch, could have been a lot of things, but I think we proved that we have the current flow, or we have a current path now. So whether it'll work, I don't know. It's still, antennas disconnected, what have you. So I feel comfortable that we have the circuit complete now. I've taken the antenna out of the holder simply because the wires were ripped loose, and so now I'm going to go through and dress these wires again, get the enamel off of them. They've got the silk winding on it and also some enamel, and I'm looking to see if there's the fourth one in here. I'm not really sure. And then I'm going to do some continuity checks and try to find this. The schematic shows that this particular one is 1.5 ohms. It doesn't give any resistance here, but it shows this to be a smaller coil than this one. So I'm thinking the highest resistance of these two coils in this loop will be this one, and then the other one will be almost a dead short. So I'm going to strip those back and see if I can do a little detective work. I found 3, and not sure where the 4th one's at. So I'll see. Oops, sorry. This may be. Here's the 4th one. I found the 4th one. So now I've got to figure out which loop is what. What I did is when I went to strip these back, it was really hard checking continuity, so I ended up putting a little flux on them. Well, before I put flux on them, I took some sandpaper and sanded them back, put a little flux on them, and then tinned them so that when they were still stranded, I just wasn't getting a good reading on it. So I tinned the ends of them. That's a little boogered a little bit, but it still is good. So I end up doing a little detective work. See if I can make it where you can see this. The number, the inner coil, I talked about it in the previous segment. This was supposed to be 1.5 ohms, and this is number 3 and number 4. But number 3 on the, well, number 3 is on the center of this antenna coil itself. These two and this one are on the outer. This is the only one that's on the inner, so I just numbered that 3 and went from there. Okay. So when I did a continuity check, let me put this on tripod and I'll show you the continuity and my logic in this. Maybe you can see this. I'm going to untie my leads. I just explained how I come up with number 3. So I've already marked these, and so maybe you can see this. There's number 3 here. Get my lead on there. And then number 4, I'm reading 2. Just less than 3 ohms, 2.9. So the other 2 is reading 0.8. And as I said earlier, the one on 3 and 4 should be 1.5 ohms, but according to the drawing, it appears to have a bigger coil than the other one. And I don't think that they would draw extra loops in one if it didn't represent something. So the one with the lowest resistance is going to be this loop, so I made those 1 and 2, and then the ones with the highest resistance I made 3 and 4. Even though it wasn't 1.5 ohms, it was still just less than 3. So I'm going to go with that, and so we'll dress these wires and get them hooked back up after we do a little bit more troubleshooting on the radio. I've pulled the tubes out, guys. We haven't gone underneath the bottom of this. You haven't seen the bottom of it yet. And I've looked. It has been recapped sometime in the past. I don't know exactly when. But I was going to show you, we're going to do some troubleshooting to do some tests from the top side. Some people say, well, that may be silly, it may not, but to me, finding tube pins or holes is easier than hunting things underneath. That's just me. So, you know, I've showed you how that we've checked this, and we've determined we had a bad tube. So let's check the speaker field, which should read about 450 ohms. I've pulled all the tubes. So if we look at this junction here and go over here, so pin 8 of the rectifier tube, the 35Z5, if we put our ohm meter there, the other end of it goes to pin 4 of the output tube. Okay, so this is the output tube, and this is the rectifier tube. So we said the rectifier or the output tube, we need to be on pin 4. Here's the key. When you're looking at it from the bottom, you always go clockwise from the key. So on top, you go counterclockwise. So there's 1, 2, 3, 4. Okay, we should be reading about 450. There goes my meter. It's timed out. Let's turn it on and off. Here we go. Now the timer's off. So there's pin 4. Now let's go to pin 8 of the rectifier tube. Pin 8 should be there. 437 ohms, 450 ohms. Now these, typically, it doesn't say, but typically these are hot measurements. So it may run a little less than. So we're good with that. Alright, let's check the output transformer, which will be pin 2 of the output tube and pin 4. Okay, we're already on pin 4. I'm sorry, that's pin 3. Goes across this, the primary of the output transformer. So pin 3 to pin 4. So we should just be able to move it to here. And it's showing about 166 ohms. The documentation says 430 ohms. Now that's a cold measurement. It's not shorted, and it's certainly not open. So could there be a capacitor? There's a capacitor here. Could there be something affecting that? Don't know. But we'll go with that number right now. For now. Okay, let's see. Let's check the IF transformer. The primary and the secondary of the first IF should be 22 ohms. So to check that, we'll go from the 12 SA7, pin 3, and we come back down and across, and we can go right back up to pin 4 of the output tube. So pin 4 of the output tube, which we already have it there, and then we go to the 12 SA7, which is the one in the front, and we need to be on pin 3. Alright, so we're going clockwise, 1, 2, 3, and somewhere on the order of 22 ohms or so. There we go, 21.5. That's pretty good. So we think this is good. So now we go to the 12 SK7 on pin 4, and the SK7 is on this end. So pin 4. So we go clockwise, 1, 2, 3, 1, 2, 3, 4, and then we want to go from pin 4 through here, and we go all the way, and we can go over here to the yellow, or pin number 4 of the yellow wire on the chassis, which is right here on the antenna. 21.8. So I think the secondary is good on that. Let's go to this one. So we want to go to the 12SK7 on the plate. That's pin 8. So that would be here. Let's see, is that right? That's 1, 2, 3. Yeah, pin 8's right there. And then we want to come down and we go over and we go back to pin 4 on the output tube. Where we at? 1, 2, 3, 4. We're reading 34 ohms or so. And the secondary, or the second IF, should be around 30 ohms. So we're good with that. Now, on the next one, we can go from pin 4 of the 12SQ7. But the problem we have here is it goes to this terminal from the potentiometer. There's a 47K resistor, and it's tied to the end of it. We've got to go to the bottom to get to that one. So, okay, let's find the one on the top, 12SQ7, which is pin 4. And the SQ7 is the one in the back. So, let's see, 1, 2, 3, 4. Now let's see if I can turn this over and keep it in frame for you. The potentiometer is here. The 47K resistor is here, and it terminates here. So we should see there's around 35 ohms. So the IF transformers seem to be good. Alright, let's hook up the antenna and bring it up on the variac. Put the tube back in and let's just try it and see what we've got. Got the tubes in, and I've got my engineering degree. I'm sorry, that's my alligator clips. I thought that was the same thing. Anyway, looking at the antenna terminal number 3 of the antenna, the connection 3, it goes up to the grid of the 12SA7. Well, this particular radio, you know, these tubes don't have the grid cap like a lot of the other types have. So the grid's on the bottom. So I traced it out, and the grid is comes up and is attached to the other side of this tuning condenser. And so I was wondering where it was connected at, but I got to look, and I don't know if you can see it or not. Maybe I can get it. But I seen where this was, there was a wire soldered to it. So the antenna was soldered to the capacitor, or the condenser right there. So that's what this is for. So I'm going to hook this up. So let me get this on the tripod, and let's bring this up slowly and see what we can come up with. I've hooked up the antenna. Now this one goes to an external antenna, but I'm going to leave it off right now and just try the coil itself, or the loops. So let's get fire in the hole and see what happens. I think I've got everything hooked up, guys. Let's see. Isolation transformer, my variac's backed off. Got my meters in line. Switch is on. Okay. Let's bring it up. There's about 25. Don't see a big spike. As I'm going to let you do like Michael at That Tube Sound. You guys watch the current as I watch this, and if it starts jumping, let me know so I can cut it off real quick. Okay, let's go to 50. Still south of 200 milliamps. Starting to see a little glow there. Let's go on up a little bit more. About 75. Am I starting to see any glow? Not yet. Other than the dial lamp is slightly. It's going up to 100. We usually see stuff about that side. I believe I'm starting to hear a hum. A little static maybe. Oh. Sounds like some sort of ball game. Let's go on up. Let's go about 115 volts. All right. Yeah. All right. Not excessive amount of hum. Check this out. Still haven't cleaned it off. Still got fuzzies on it. All right. Just with a loop. Hook up the external antenna. There's with the external antenna. There's without. Definitely makes a difference. All right. Low end of the band. Let's hook the antenna up and see. Some heterodyne down in there. Some birdies. Maybe need some alignment.
You know, next year is the proving year.
All right.
And everything that that he's all about, but Kuzma's leading this team.
There's my local favorite, oldies. Sounds pretty good, don't it, guys? All right. All right, let's, we're just shy of 300 milliamps. That looks pretty good. Definitely need a recap, some cleaning up. I think we'll have a great sounding little radio here. All right, I hope you learned something there. I did. And in the next series, we'll recap this and maybe get that dial in and get it all back together in 2 to 3 series, in 2 to 3 parts. Sounds great. Oh yeah, 2025, huh? All right, guys. I appreciate you for watching, and I just want everybody to have a real happy Thanksgiving. From the hills of Tennessee, this is Larry. Thanks for watching.